Okay, today I'm going to talk over the cumulative number 6 review packet. This is reviewing for the last cumulative test of the year, and once we're done with that, all you have is the final. Okay, so last cumulative is on this Friday. So we have 2 days to talk. So today we're going to cover the first 3 sides of pages, or 1.5 pages of this packet. So here we go. Number 1, it asks you to write a limit for something, but I need a picture before I write a limit. Like if I was graphing something like this, then I'd know that the limit as I went to infinity would be infinity. You remember how the limits work? So on number 1, you might want to write this part down. Lim of the function as x approaches equals. That's how you do every single limit that you've ever done. You write this whole part out, and then you got to put the x part tells whether you're going way to the right or way to the left. And this is the y part of the answer. It's how high will it be when you get there. So what is the picture in this case? Well, it tells you this. Y equals, what kind of a fraction was it? 2/3 to the x. Is that growth or decay? It's decay. It's decay because this is a small number smaller than 1. So therefore, it generally looks like that. So as I go to infinity, which is this way, the y value is closer and closer to 0. So this would be one of your limits. And then, of course, the other one is the other way. Going to go way this way towards x is negative infinity. Yes, sir? Good question. The number in the parentheses is negative. We will just simply not do that to you because that would change. That would be a flip, and it's not something we're used to, and it would not be something to throw in on a final or a cumulative. So let's not go there. All right. What you do need to know is when you see something like this, that if there's a negative in the exponent, that means that that's the same exact thing as if I had done this. Actually, let me replace that. I'll just keep it simpler. 2 to the negative x. Do you get that that's the exact same thing as 1/2 to the x? And it's more clear when you write it that way that we're talking about decay, right? All right, let's talk about that a little bit more. What if you had this, 3, and this is 0.7 to the x? My starting value is 3. It's like I have 3 pogo sticks. And then for some reason, I'm losing a percentage of my pogo sticks every year. And so I'm losing, what percent? Am I losing 70%? No, I'm losing 30%. Okay, I don't know. I shouldn't have used pogo sticks. Fine, 3 gallons of water. I had 3 gallons of water, and I lost 30% of it due to evaporation. Okay, so then I'd have, well, would you agree this is the exact same thing as this? Because 0.7 is the exact same thing as 1 minus 0.3. And why is it smarter to write it like this? Because now you know that it's decay of 30%. It is not 70% decay. See, that might make you think that. It's 30% decay. But yet, if they ask the growth or decay factor, this is the growth factor. This, or decay factor in this case, this is the decay rate. 2 different things. I know that's confusing. This one's the decay rate. This one's the factor. All right, so if you saw this, let's say that there's 112 of those big lizards that are Komodo dragons. There we go. 112 Komodo dragons on the island. And they've been getting busy of this happening. What does that mean? Who says that anymore anyways? Old math teachers. So it went up 20%. So their growth is 20%. Yet, what would the growth factor be? This whole thing put together, which is what? 1.2. That's the growth factor. All right? The growth rate is 20%. All right. So how about we move on to the next kind of question? Let's look at number 3 then. So look at number 3 quick, and if you recognize what I just was talking to you about, that the 5 is the starting value, and then what's that 4? There you go. Done. Your rate would be 300%. Very good. Because that'd be like 1 plus 3. The rate would be 300% growth. But the growth factor is 4. You getting the difference? Okay, yes? I was arguing that it was not 400% growth. It isn't 400% growth. It's 300% growth. But it is a growth factor of 4. Now, I know it's kind of like, it's annoying to have two words that are so similar to each other. But I do want you to know this because I know what's coming. And they're going to ask you questions like, let's say there's a 57% decline in the amount of fish in the ocean. And there used to be 5,000 when sampled. And now there's been a 57% decline. I don't want you to go like this. Yes, 1 minus 0.57. 57% rate of decay means I should do 1 minus that. So then what's the growth factor or the decay factor? Actually put this together and you get 43.43, right? And that would be the factor. This one's the rate. This one's the factor. Okay, but there's two different questions here. What if the exponent is negative? Whole different situation. Do you agree that that's the exact same thing as that? Then I would think of it that way. Now you know, you can look at it this way and say, okay, now I know it's decay. How much decay is it? It's not 25% decay. Yep. 75% decay.
That's not right. That's going to say it.
No, that's right. 75% decay. And it's the growth factor is 1/4, or the decay factor. All right, anyway, let's move on from that. There's stuff that's more important than that. Let's move on to like number 6. That is a whole different kind of function, and that is called a basic logistic function. It says this. Stay with me, please. We're on number 6 right now. I don't even want to address that. Just no, you weren't. Let's not talk about what you were doing either. Okay, equals 15 over 1 minus e to the negative. And is that okay? Yes, that's normal. Plus, sorry. Okay, is that right now? All right. So on number 6, that's the normal way to have. It's okay to have a negative right there. That's the normal way that basic logistics work. Because that's the same as 1 over e. There's supposed to be a fraction right there. Otherwise it wouldn't, it's on the bottom and so it wouldn't actually grow if you didn't have a fraction right there. So anyway, that's a normal one. So the really long and short of it is, that is the limit to growth. Done. That's all I asked you. What's the limit to growth? We're going to have to know more about these in a minute though, so I'm going to remind you generally when you make these things, they look like this. They limit off at some number, which is the top of your fraction. They also are obsessed with that point, which is the starting value, also known as the y-intercept, and you need to be able to finish this sentence. The y-intercept is where, what? X equals 0. So all you got to do is stick in x equals 0 and crunch the numbers and figure out what it comes out to be. 2 times 0 is 0. That's all 0. Anything with 0 power is a 1. So this is really 15 over 1 plus 1, 15 over 2. See what I'm saying? So the y-intercept is the same as the starting value right there. It's important. We'll get back to more of those in a minute. Let's move on to number 9. Number 9 is a graph, and notice it's not going to turn and start leveling off. That would be cheating. They can't do that to you unless they tell you it limits out at some future time. So then that means this has to be exponential growth. Starts at 0,3, has another spot at 2, 6. And we have to assume it's going to keep growing. So what is the base model for it? A, b to the x. Do you remember how to do these? You take this point, you stick it in here into the x and the y, and you'll figure out the starting value, which is this number. So you use this point to figure out the a. Once you've done that, it won't be hard in your head. You can probably figure this out, and you realize that, oh, a is 3. And then you'll have y equals 3b to the x. Then you use the other point, this point here, to stick into the a, or the x and the y, to figure out the b. All right, you remember those? I hope so. Okay, moving on. Yes, the final is only on this semester. Okay, flip it. Look at number 10. On number 10 is one of those kind I was talking about where they say it's decreasing at a rate of 0.57% per week. Now notice that's not 57%. It's decreasing by 0.57 per week. So it goes like this. Starting value goes here, whatever it is. And then if this is decreasing by 0.57, do you remember how I start? 1 minus the 0.57, and that would be 57%. So I did something wrong. 0.0057. Very good. And then it's to the x. And then what was the starting value? Whatever it was, just slap it there. Okay. Ooh, I didn't even notice that one. Hold on. If it's per week, I think that's a flaw in the problem. We should do the whole problem based on weeks, and then we don't have to worry about that. I know what you're talking about. That's a different kind, though. It's a different kind of question. If it had been like okay, it's doubling every 3 days. Those are the kind where you go like this. Doubling every 3 days in days. That's a good kind of problem to know how to do too, but that's not what they're talking about on that one. Okay, let's move on to number 11. Everybody look at 11 with me. 11 says, find the logistic model. Oh, so it's one of these. Y equals some number on the top, the limit I'm going to call it, 1 plus a b to the x. That, you got to know when they said logistic, that's the logistic thing. I'd be writing this down if I were you. Then I'm going to put in numbers I know. The initial value is 10. Ooh, seems like, wait a minute, I'm going to draw a picture. I think it'd be better to have a picture of this. Picture's worth 1,000 words, right? It says initial value is 10. That's 10. So it's 0, 10. It'd be really tempting to stick a 10 right there. You cannot. That is not okay. I had about 1/4 of the class do that. You think, oh, starting value is always the a. Nope. Starting value you put in for x and y, and you figure out what a comes out to be. So if I'm going to use this 0, 10, I'm going to stick it in 0 here and a 10 here, and I'll have to figure out what the a is. The limit to growth, they'll have to tell you. It's 600, so I can just slap a 600 right there. And then, again, you use your 2 points. This point tells you your A, and your other point that's they tell you is coming is 15, 300. That's the point you use to figure out your B. All right, moving on. Just a little shot on graphing here. Number 12 is a graphing. Do you remember the basic ones? I'm going to just sketch them quick, and you may want to write down a reminder for yourself of what's the parent graph look like? Because all you really got to know is parent graph's been moved to the left or the right or up or down. So what's the parent graph for, what's that one called? Exponential. That's y equals e to the x. What if I'd said y equals 3 to the x? Wouldn't it look almost identical? Because what is e? 2.718. So y equals e to the x is pretty much the same thing as y equals like 3 to the x. I'll make it a little more dramatic. Let's say it was y equals 5 to the x, then it would be a little more steep. We'll still go through the same spot, though. I have alignment issues I'm going to fix. There we go. So that would be like y equals 5 to the x. Then there's the other two, which are this way. The one that makes a really sharp turn, do you think that's log base 10 or log base e? Log base 10. The really sharp turn has the bigger base. Log base 10 of x. And then the one that doesn't make as sharp a turn is log base anything else. I'm going to say like 5. If you wanted log base e, it's just another one of those, just has a little bit, you know, it's a little bit looser. Okay, so there's the parent ones that you have to know. Looks a little bit like a butterfly. All being reflected over the line y equals x, which means there's inverses involved. And now we just need a couple of like little things to have little feelers. Anyway, moving on. So let's say you had a problem like number 12 then. Y equals, about 8 minutes left. 3 to the x minus 4. Well, I know what 3 to the x looks like, generally like that. And what does that minus 4 mean? Moves it down 4. So then, remember there's an asymptote. They're going to ask you, graph all asymptotes. The asymptote on this puppy is like right here. If I'm going to move it down 4, the asymptote will move with it, so it moves down 4. And now here's my new graph. There we go. Now, if I'm off a bit, but I've got 2 points and the asymptote graphed, I'm fine. Do you remember that deal? So, in an XY chart, need at least 2 points verified. So how do I check 2 points on this puppy? Pick anything you want for x, but pick smart. Don't pick like 23. That'd be a pain. Sure, 1 for x is good. 3 to the 1 is 3. 3 minus 4 will be negative 1. So 1 comma negative 1. 1 comma negative 1. I'm off a bit. I'll have to adjust that in a minute. Now I'm going to try, actually that's, yes, I can put in a 0. A 0 would be smart. If I put in a 0 for x, I get 1 minus 4 would be negative 3. 0 comma negative 3, well, that looks like it could be believable. So I guess I just should go a little more steep like this. So I was close. So now I have 2 points in the asymptote right, and I'm good. Remember that? That's how you do 12, 13, 14, 15. I want to remind you about 15, because on number 15, it's got the thing written kind of backwards. Log base 2. I know how to graph that. I hope you do. It's just kind of like that-ish. And then it's been moved, though. And I'm not going to say 7 minus x. I'm going to say negative x plus 7. Very good. And that will remind me to do a flip and a move. And these are tough. A lot of people got this wrong on the test. So if I do it, I'm going to move this thing to the left, 7, and then flip it. Or should I flip it and move it left? Does it matter? Yes, it does. When you're on the inside, you've got to do it in the right order. What's the normal thing to do? That's the normal thing to do first because it's multiplied by negative 1. So we don't do that. We have to do this first. I have to move it 7 to the left. So I'm going to grab this thing here, move it 7, and it's asymptote with it, and I'm going to move it 7 to the left. Okay, now this is tough. I have to flip the whole thing left-right. I would start by flipping the asymptote left-right. That's fairly easy to see. The dotted line has to move over to here then, right? And then if I'm going to flip this line with it, left-right, it's going across this asymptote right here. It's going across this line. Then the new answer would be, I'll make it red like that. People make the mistake of trying to flip it over the asymptote line. You don't. You do reflections over the axis, the y-axis in this case. The final answer is this red line and this red asymptote right there. You're right. Got to have 2 points, x, y, and then you pick smart things to put in. Like I want to make this whole thing equal 2, so I'm going to pick x to be 5. You know why I did that? Because now I have log base 2 of 2, and I know what that answer. What's that? Log base 2 of 2 is 1. Okay, so then I know it's 5 comma 1 is on there. Over 5 up 1, let's say it's right about there. And check another point. Anyway, I don't want to do all these problems for you. Moving on, I want to get through this last page in the last 3 minutes. So I've already talked about graphing, so 16 and 17 are out. 18, that's all fresh stuff we've just done. So that log base 2 of 32, you should be smart enough to go, oh, I can rewrite 32 as 2 to the 5th. And what's the answer? 5. On the next one, I can rewrite, on part B, I can rewrite ln of 1 over root e to the 7th. I can rewrite that as ln of e to the something, because then it's log base e, you know, of to the something. And if I can only figure out the something, the power, I'll be good. So negative is right. Negative 7 is not good enough. Negative 7 halves, because now I got a square root involved. That's this guy, and that's this. And I got the power of 7 involved. That's this. And I got the fact that it's 1 over. That's this negative sign right there. So there we go. All right. And let's... 19 and 20 are just rewrites. If you don't know how to rewrite yet, you're in deep trouble. All right, finished with a minute to spare. All right, so after lunch, sweet, we can't go to lunch quite yet, but to stay, finish a problem or two. After lunch, I'll be giving you your tests back. You are going to really want to do your corrections right